Okay, so today we are going to learn how to visualize large amounts of data, how to create multiple graphs, how to make settings for data series, and so on, and how to automate calculations. Also, we are going to see different forms of functions. It's like a little bit training with math. We are going to see how to present functions in different coordinate systems, and at the end we are going to discuss your individual tasks. Let's get started. Well, first of all, let's have a task. So the goal is to learn how to analyze large amounts of data. When I say large amounts, it means that there are hundreds or thousands of values, and you need to process, somehow analyze this really huge set of numbers. And the only way to do it quickly is to make a graph. And sometimes it's not just one graph. You need to analyze behavior depending on some parameters. So usually when we study a system, when we learn properties of any object, we can get different results depending on state of this object or the parameters. And let's, for example, have a function. Let's start somewhere here. The function is y equals x minus a everything squared. Use font settings for superscript symbols. So this is the function. And this function depends on parameter a. So here x is input argument. And we are going to analyze behavior of this function depending on parameter a. And somewhere we have values of a. For instance, minus 1, 0, 1. So this is the input values. And we are going to have a table y1, y2, y3. And when we organize the table, we can also merge cells. In order to have one huge cell, you need to select several cells. And look, there is instrument merge and center. You can click, and now X is for two cells, A6, A7. And the same goes to merging horizontal cells. So this is our table. We can center everything using these instruments. So we have everything looking nice. And actually this is it. When you have some real tasks, some real life work, you have the goal to analyze the function. You have some conditions, And this is it. Now it's up to you how to deal with this function, how to analyze. And now you need to try to guess what result you are going to have for different values of a. What values of x to choose. So it's like a process when you try to adjust input parameters and choose the most appropriate input values. And this function is a parabolic function, and it has shifted center, so it's not in the center of the coordinate system. It's somewhere on the left or on the right. So it's just because I know math. And the domain of this function is any values from minus infinity till plus infinity. There are no specific points where the function turns to infinity, or when we have uncertainty 0 divided by 0. So let's choose range from minus 4 till 4, and the step also defines the result. We can have minus 4, minus 1, and so on. We can choose a smaller step like minus 4, minus 3, minus 2. We even can choose a really tiny tiny step like minus 3.999. So it's 1,000th part. And actually the result analysis of the function depends on the step. If it's a really small step, I guess you won't see any big difference between a step of 100 or 1/10. If you choose a step like minus 4, 0, plus 4, and this is it, it's not enough points to make a proper graph. So it's always a result of thinking, analyzing, and you should choose the most appropriate for this situation step. I would say that for me step minus 3.8 0.2 step is enough. So let's have this step and calculate values until 4. Define the first value minus 4. Define the second value minus 3.8. Select cells and drag down. In this case I have 40 different values. It's not a really huge data set, but if we choose a smaller step, 0.01, in this case we are going to have much more. Did you calculate x values? Do you have this column on your computer?
Yes.
Great. So now we are ready to find the values of the function. And it's just the usual procedure. We start equals, choose relative reference to the x value. In my case it's 8A8, the cell on the left, minus the value of parameter a. and I'm going to use one formula for all cells. So that's why I need to fix column A here, and I need to fix the third line. So I'm going to use B3, C3, and D3. So that's why I need to put dollar before 3 and square the result. One more time. This is the formula for finding fixed column A, fixed third line. And press enter. Apply it to the first, the second, and the third. Also, we need to check the result. It's essential part of any work. You need to compare the results with expected ones. Let's say we have -2. -2 minus -1, it's 1. Squared is 1. This value is okay. -2 minus 0, it's -2. Squared, it's 4. -2 minus 1, it's -3. And double 3 is 9. 3 times 3 is 9. So this table is absolutely correct. And now we need to create a graph. And the function depends on x value, so we have two coordinates in the rectangular coordinate system. And let's insert a scatter diagram. We do not select anything here yet. We just click insert and then find scatter diagram. Excel automatically tries to guess what you want to plot, but it's not sometimes it's not working all the time. So I'd like you to create an empty chart. Charts, insert. Okay, select empty cells anywhere and click scatter diagram. In this case, you will have empty chart, absolutely empty chart. Select somewhere empty cells, click insert, and choose scatter diagram, for instance, the third pattern. Okay, now we need to add lines. We need to create curves, add data. In order to do that, right click somewhere on a graph and find option select data. You will see a symbol of a table. Select data. When you press OK, you are suggested to specify series of data. Let's remove this blank series, we don't need it. The button Add allows you to add a new series of data. When you click here, you are suggested to specify a series name. We can make reference to Y1 caption. Series of X values, so you need here to select the input values. And Y values. Here you can see number 1 in curly brackets. It's like default value, so please erase it. And specify the range that has values of Y1 form of function. Now, the preview result allows you to estimate correctness. We start from -4 and finish with 4. So it's okay. We've selected all values. Press OK. Now we need to add the same way 2 more lines. Please click Add again. Select caption with Y2. Select X values. And select the values of the function. Press OK again. Now we can see two curves on a graph. And again, add Y3, X, and Y values. Eventually you must have 3 different lines. And if suddenly you have chosen wrong range, you can select one of possible options here and click Edit. Again, you can see this form that allows you to specify another range. Okay, I've suddenly erased everything, so I gotta do it again. Okay, so this is the result that you should get. Do you have the same? Or you need some time to finish? Okay, good. Now we need to analyze the behavior of this function, and also we need to understand clearly what conditions we have for each graph. And here we need to create a legend. Let's add a legend to this graph. Chart elements, we need legend. Also, you may click to a graph, find design page, and on the left there is an option add chart element like axis titles. Let's add titles too. Let's add chart title. We can actually copy the header of the table. And here this is y values. In this example, the measurement units are not defined, so we just have numbers without any measurement units, meters, seconds, or volts, and so on. So it's just x and y. And we can specify legend on the top, put it somewhere on the right, and here parametric function. Here we are. And now in this case it's not really clear what this y1 is about, and we can actually select data, specify here that this curve is for a equals -1. No one forbids us to just specify manually. We can type here that this is for a equals 0, and in this case we have automatically changed option. For the blue one it's done manually. I just select data, edit, and manually say that this equals to -1. The second way, I have a reference to SLC7, and this one let it be just Y3. And what if I need to change it? For instance, -2, and this one number 2. You see, now the caption is not according to the input data. Here, for the blue one, I gotta edit this caption manually again, -2. For this one, I have to edit SL C7 and say this is 2. And you see, even if I'm using a cell, a ready cell with the text legend, it's still inconvenient because basically I have the value here and I need to duplicate to type again this value but in the form of a text message. This is absolutely inconvenient. And in Excel there is a special function. So let's have values for legend additionally here. And we need first to use the parameter's name, which is a variable. We need to use the value of the parameter. In this case it's minus, let it be 1 again. Minus 1, 0 and 1. Let's have it again. So here we need to make a text that displays something like a equals minus 1. And in order to do that, there is a function which is called concatenate. Concatenate. And inside we need to specify a list of text values, text 1, text 2. Look carefully at the separator that is required for your operating system settings. In my case it's semicolon separator. It might be comma on your computer. So let's concatenate A, then separator, and also we would like to see that A equals, so we need to use a constant. So there is actually no need to use symbol of equality just as additional cell. We can actually specify it in double quotes as space equals space. When we use double quotes, this means that we are using a text constant, and this is going to be all the time for all possible situations. Space equals space. Then semicolon again, and text number 3 is the cell with the value B3. And close the bracket. And this is it. Press enter, and look, we have a caption: A3 equals minus 1. When we change it minus 2, it's automatically replaced with A equals minus 2. The values of the function automatically recalculated, and the graph is automatically replotted. So we just change here minus 5, and look, everything happens without any movement. So this is the point of automatization all the time. You try to make a table, organize data inside the way that allows you to do minimum actions, minimum steps. And when you prepared the table looking like this, it is really quick. When you change the input value, see immediately the result, and you can concentrate on analyzing the function rather than to do routine work with changing parameter values, recalculating again and again, plotting. So when you find the value and make a graph, it's a regular action. You do it all the time, and the point is to spend more time for your work. So you're paid for analysis, for the result of your making decisions. So you need to concentrate on the work rather than to do this technical solve these technical problems. So let's go back. Minus 1 0 1. Apply this formula to cells C1, and we have a problem that I forgot to put dollar here, so we need to use absolute reference for A3. So this was a mistake. And actually note that Excel doesn't care about the format of input values, text in the form of letter A, number in the form of number -1. Eventually it's all text. Okay. Now it's correct. A equals -1, A equals 1, so we can put add some colors to show what you can change. And actually it's like a ready template when you need just to change these values. And this is it. All the rest is automatically except the range of x values. And let's correct the data here. Select again and edit here, and in this case we are going to have references to the legend table. In my case it's reference to B4. Press OK. In this one, edit, it's gotta be name from C4 cell, and the last one, edit A equals 1. Press OK. And when we change here, the legend is also according to the value in the cell C4. Have you got the same graph? Okay, when you're ready, send plus in the chat so I can see that you have finished this part of the exercise. If you need something to repeat, please say. Okay, Lipen has finished. What about the others? Xiaoyin, have you plotted the graph? Great. And now we finally ready to do our job. We have a function x equals y equals x minus a everything squared. We have three situations: a equals -1, 0 and 1. And looking at the graph, what can you say about behavior of the function? How the parameter a influence the shape, the form of the function? When it's 0, we have the orange graph. When it's -1, it's the blue one. When it's +1, it's the gray one. Try to formulate briefly how a changes the function. Well, look, if it's not clear, for these three cars you can actually add several more, or you can change the values of the parameter a, for instance -2. And you see, when I have -3, the curves moving to the left. When I have +2, the curve, the gray one, moves to the right. So generally, this a parameter moves the position of 0. So it's like shift for this function, or offset. But usually offset, it's horizontal, vertical position. And in this case, we change the x value when the y function have 0. The point where the curve crosses the horizontal axis. And that's how you are going to analyze your individual functions. You have the formula. You need to make a table looking like this. You gotta choose the values of x that allow to understand the function shape. You choose the proper step. You choose parameter values. The point is to understand how exactly parameters of the function influence the result. And Lab5 is available already on our electronic course. Here you can find Lab5 description in the Lab5 PDF file, and also you can find the link with the video from today's class. And let's open Lab5 description. The work is called Visualization and Analysis of Large Amounts of Data in Microsoft Excel. Here you need to learn how to make multiple graphs, what is the main steps of adding series of data. Also, you need to make an electronic report in Microsoft Word, as usually. And also, we need to learn some basic rules about representing values from one coordinate system to another one. Generally, there are three different types of coordinate systems. Here we have three-dimensional case. The first one is rectangular coordinate system. It's what we are get used to using all the time. It can be dimensional x and y, or three-dimensional x, y, and z. And it is also possible to present everything as a vector. So it's like a vector that starts somewhere on the vertical line, vertical axis, and we specify the length of this vector and the polar angle, angle phi. And we have three coordinates: length of the vector, phi angle, and the vertical coordinate. This system is called cylindrical, or if we have a two-dimensional case, x and y only, this coordinate system is called polar. And finally, if this vector starts from the beginning of the coordinate system, we can describe any point in three-dimensional space using the length of this vector, angle phi, and angle theta. So it's two angles and the length of this vector. And in order to recalculate from spherical coordinate system or from cylindrical one to the rectangular coordinate system, use the formulas suggested here. For this current lab, we are going to use the formula for x, the formula for y values. We are not going to make three-dimensional plots, just two-dimensional, and these two will be required for representing from polar coordinate system to the rectangular one. And if you have spherical, you will need these formulas, but we won't use them for this lab. It's just for you to know the formulas that connect two different coordinate systems. And here you're suggested to do exercises similar to the exercise that we have today. Please follow this instruction. For instance, you need to make a graph that have several parts, several functions. For instance, function 1, function y, you have the formula for it and the domain of this function, that absolute value of x must be less or equal to 4. G function, x modulus of x is in the range between 1 and 3, including these numbers. H function, it's piecewise defined function, so it's like the function that we used in the task 4 in the lab 4. And the final one is also a function, but here there is a peculiarity. We here calculate values of x, so it's vice versa. We specify values of the function, so it's a range of the function. And using this range of possible values, we calculate values of x. So it's this form of function is called explicit. These functions y, g, and h, this is called just a second. Yeah, it's vice versa. Y, G, and H, it's called explicit form. This function has implicit form. Implicit, when it's not direct calculating of y of the function values. Here we calculate, we can see a form, and we need to solve this equation in order to express values of the function. And when you try to make a graph of these four expressions, you will have a really interesting result. So this example shows you how to make a table, how to organize a table step by step. Please train at home. So one of the functions is this curve, and finally we can draw a really nice picture using these formulas. And I guess after that exercise you will really like math, because math it's not about formulas, calculating, finding numbers and so on. Sometimes it's work with graphs, with functions, and the result might be really interesting, beautiful. I guess it is clear what this symbol is about. And please try to do this at home. I believe you will have much fun. Alright, and now concern with your tasks. The task 1. According to your variant number, you need check the table 1. In the table 1, the function is given explicitly. You have absolutely different functions. They have interested names. So for this example, it's hyperbolic sine function. It's actually this formula, but in math it's marked as SH. So this means hyperbolic sine function. You are provided with domain of the function and maybe some restrictions for parameter. So in this case, parameter a cannot be equal to 0. And train this example first. Organize the table according to the suggested pattern. Try to find the appropriate range of x values, appropriate step. Organize the table with automatic captions and everything, and you will have this result. If you do everything correctly, the result is gonna be as it's shown in this figure. Then you need to analyze how parameter a influence the function. And this is really important, because I'm going to take points from you when I see no conclusion. So generally, you have a section, task 1. Then you say, my task is to analyze the function, this one. This is the input conditions. And somehow briefly describe how you make this table. And insert this picture. It is not actually necessary to take a screenshot. You can just copy this graph and insert it in your report. And please analyze in details how parameter a changes the function. So here, particularly, we can say that when a is negative, the function is in the second and in the fourth quarter of the coordinate plane. If a is positive, the function is in the first and in the third quarters of the coordinate plane. And now we can compare a equals 1, a equals 2. And the more we have a, when a grows, the function values goes down. So we decrease values of a function when we raise value of parameter a. So that's how you are going to analyze and explain the function behavior. Try to do it on your own words. It can be 3-5 sentences. For explanation, I guess it's enough. Now, then go to the table 1. Fading 1, table 1, and task 1, analyze a function in explicit form. If you variant number 1, so this is your function. If you variant number 2, this is your function. If you variant number 3, this is your function, and so on. So the first column is task 1. Then task 2. The function is given parametrically. So this means that you have argument, for instance angle phi, and coordinates here x and y are parametric. You should use absolutely different formulas for calculating y values, for calculating x values. For instance, your function is called hypercycloid, and y values are found with the use of this formula, x values are found with the use of this formula. The domain of the function is angle is between 0 and 2 pi. A and b must be greater than 0, b must be greater than a, and b divided by a must be integer number. It is important. When you have this condition, this means that you need to try different combinations of b and a. So it's not necessarily one parameter. You need to understand separately how b change the function, how a change the function. And sometimes the function depends on the ratio b divided by a. The description is given in the text form for your convenience, and organize the table. So here for each curve you will need 2 columns for x1, y1, x2, y2, x3, y3. So this is an example of your result here. And look, this is the hypercycloid function. For the yellow one, b equals 6, a equals 1. For the blue one, b equals 6, a equals 2. For the green one, b equals 5, a equals 1. And if you look closely to these changes, in the beginning there were 4 parts. Then we have 3 leaves, and the last one is 5. You can try to guess how number of these parts, of these petals, depend on b and a. And this is your conclusion here, how b and a define the shape of the function. I'm not going to announce it right now. Try to think it over on your own. And the task 2 individual is the second column. If you number 1, you have hypocycloid. If you number 2, you have cardioid. If you have number 3, strophoid, then astroid, and so on. And finally, the last task. The task 3. The function is given in polar coordinate system. So it's still parametric, but it's given in the polar coordinate system. Basically, you need to calculate values of the vector. You have input argument, which is phi angle, and in this example it's Le Maçon of Pascal. In order to make a graph, you need to recalculate values in polar coordinate system to values in the rectangular coordinate system. So that's why we will need to use these formulas. Separately calculate values of x, separately calculate values of y. Down below you have some pattern how to organize your table. Now we have angle phi in degrees. We need to recalculate angle into radians, and then we need to calculate values of a function. But for plotting we need to use x1 and y1. Also use concatenate function to make automatic legend, and this is the result. That's how Le Maçon of Pascal looks like. I also recommend you to check on the internet the expected result. So if you, for instance, have Le Maçon of Pascal, this is your function. Well, the first thing that you can do is open internet and check what Le Maçon of Pascal is. You will find lots of information, lots of examples. You can watch a video, and when you learn in general your expected result, then you're ready to start doing your individual task. And at the end there are some control questions. Give answers in your report at the end of your report, and the assessment criteria. As usually, you can get 20 points for this work. The work is passed when you have 15 and more. I'm going to check your report. Please read this criteria. I'm going to check separately each task. Task 1, 2, and 3. They have the same criteria. I'm going to check your quality of graphs. They must have legend. It must be automatic. It must have title, axis captions, adjusted scales. So sometimes I saw graphs like a really huge graph and some tiny part is your function. Come on, it can be hardly understood when you see this small part, try to make parameters of axis so we can see the whole graph. So uh, your graph demonstrates the whole function. For instance, we have several curves and you need to choose. So you can specify this range, the minimum and the maximum value, displayed value, when you format axis. You can make settings for bounds, for the horizontal axis, for the vertical axis. So choose the best value. And the last criteria is the deadline. This work is not really a huge one. So I'm giving you, I guess, 2 weeks. We have one more class on the 28th of April, where you can show me some results and ask questions. Then you have one more week, and the deadline for this lab is the 10th of April. So generally it's 1, 2, 3 whole weeks. I guess this is more than enough. 3 whole weeks to finish this lab. You can find this information here in the submitting form. April the 10th is the deadline for this lab. In the meantime, I'm checking your reports, and if you need some corrections, I will let you know. Your results are available in my cloud. Here you can always find all the materials, Lab5 description. Here there will be video Lab5. There gonna be only one part, and documents with your current progress. Any questions are welcome. Okay, let's see. Today is the 21st of March, and we have Alexander here, Xiayin, and Li Pen. So any questions from you? You can also ask about Lab 4 if you have some difficulty there.